In this video, let us discuss about flag registers in microprocessor 8085. Flag registers. Flag registers are called special purpose registers. They are also called as status registers because they represent the present status of the central processing unit. The size of the flag registers are architecture dependent, which means that we cannot alter the size of the flag register which is already inbuilt. In 8085, the flag register is a 8-bit register. The 8 bits in the flag registers represents the result of arithmetic or logic operations. Based on the each arithmetic or logic operations result, flag bits are set to 0 or 1. Next, let us see what are the types of flags available in 8085. There are 5 flags in 8085 that are set or reset according to the result of each arithmetic or logic operations. Those 5 flags are named as carry flags. Carry flag, zero flag, parity flag, sign flag, and auxiliary carry flag. Now, let us discuss each flag briefly. Carry flag. As the name suggests, this carry flag is set to 1 if a carry is produced or reset to 0 if a carry is not produced by an arithmetic or logic operation. So, if we do an arithmetic or logic operation, during that operation, if we get a carry, this carry flag is set to 1. If we do not get any carry, it is reset to 0. For example, let us add two 8-bit numbers. If the result obtained is less than FF, that means no carry is obtained, the carry flag is reset to 0. If in case the result is greater than FF, then a carry will be obtained and the carry flag is set to 1. This same carry flag also serves as a borrow flag when you do a subtraction operation or we do a compare operation. That means when we try to subtract a bigger number from a smaller number, a borrow is needed from the next bit. During that time, it serves as a borrow flag. Next flag is zero flag. This zero flag is set whenever the answer obtained is 0. So, the 0 flag is set to 1 if the result is 0 and it is reset to 0 if the result is not 0 during any arithmetic or logic operation. For example, let us do a subtraction. Sub b. That means we know the sub b implies that the content of the A register is subtracted with contents of the B register. For example, A register and B register have the same data. Then A minus B will yield 0. The result is stored with result will be stored in the A register. In that case, if the content of the A register is 0, then 0 flag is set to 1. If it is not equal to 0, then 0 flag is reset to 0. So, if your answer is 0, 0 flag is set. If your answer is not 0, then 0 flag is reset to 0. Next is parity flag. As the name tells, pairs. If the number of ones occur in pairs, then this flag will be set. Generally, this parity flag is used to indicate the number of ones in a given byte. We know what is a byte. combination of 8 bits, we call it as an 1 byte. A byte is said to have a even parity if it contains even number of ones. Look at a byte given in that bracket. So that byte has a 4 ones, so it is said to have an even parity. The byte is said to have an odd parity if it has odd number of ones. See, the byte given in the bracket, it contains 5 ones, so it is said to possess odd parity. If in case the data in the accumulator has even parity, the parity flag is set to 1. If the data in the accumulator has an odd parity, then the parity flag is reset to 0. This parity flag is highly helpful for error checking during serial communication. The next flag is sign flag. This sign flag is used when we work with 8-bit signed numbers, that is either positive or negative numbers. The signed numbers are mostly represented by most significant bit MSB. So we know the most significant bit is D7. This D7 is used as a sign bit. If D7 bit is equal to 0, the number is said to be positive. If D7 bit is 1, the number is negative. The sign flag is set to 1 if D7 bit is 1. That means the sign flag will be set if the number is a negative number, and it is reset to 0 if D7 bit is 0, that is if it is a positive number. Auxillary carry flag. This auxiliary flag is set to 1 when a carry is generated at digit D3 position to D3 position and it is passed on to the digit D4. So this is done internally within the processor, which is not available to the user. So this flag is used only internally for BCD operation and it is not available for us, that is for the programmer. These are the 5 carry flags available in 8085. This represents the bit positions in flag registers. You can see the 8 bits in flag register represented by D0, D1, D2, D3, D4, D5, D6, D7, the 8-bit flag registers. D7 bit, yes, that is the sign flag register. D6 represents 0 flag. D5 is it is a not very condition. D4 is AC. D3 is, it can be either 0 or 1. D2 is parity. Again D0 is carry flag. So this is not important from the point of view of examination, but it is important to know while you write a program. So all these flag registers are not affected during any data transfer instruction, but all logic instructions and many of the arithmetic instruction affect all the flag registers or all the flags available in the flag register. Increment and decrement operation involving 8-bit registers do not modify any carry flag. But increment and decrement operations involving 16-bit registers pairs also do not affect any flag. 16-bit additions using register pairs modify only carry flag. These are some of the key points we need to remember while we write a program.